Okay, guys, welcome to our new unit. We're going to start focusing on rational numbers, opposites, and absolute value. Okay, so we're going to get started. The first thing we're going to talk about is something that you guys have probably talked about last year, but we're going to talk about it again, is the word integers. Okay, integers are all of the positive and negative whole numbers. There are no fractions or decimals that are integers. So in other words, if you look on a number line, you have 0 in the center, and all of your positive integers are 1, 2, 3, 4, 5, 6, and so on. Therefore, your negative integers are -1, -2, -3, -4, 5, -6, -7, and so on to infinity. These are what we call integers. Okay. So we're going to talk about how we graph integers on a number line. So you always start by drawing a number line. And I have one drawn for us. Now, when you draw your number line, you put 0 in the middle of your number line, and you're going to do 1, 2, 3, 4, 5, maybe to 10 or 6 or 7, and all from 0 back to whatever, -5, 6, 7 on here. All right, and it says graph an integer by drawing a dot at the point that represents the integer. So these are already done for you. If you look, all we have to do on our number line, if we have an example of -6, then I'm going to come and put a dot right on -6. If we want to graph -2, we're going to put a closed dot, and when I say a closed dot, that means a dot that's been filled in, right on top of the crosshair of the line and the little crosshair right here that is -2. It defines -2. Okay, if I want to do 3, I put a closed dot on 3, right on the crosshair. And these dots are a little off, but it doesn't matter because I can tell based on the fact that it's on the crosshair, and the dot's a little bit bigger than I need. But it is graphing -6, -2, and +3. Now, I know that some of you guys in the past have been taught to draw your dots above the line. We don't want you doing that in 7th grade. We want the dots on the line, mainly right there on those crosshairs, the little hash mark that represents the number. This is the expectation for you graphing a number on the number line. Okay. So if we go to the next page, graphing integers on the number line, we are going to graph -7, 0, and 5. Okay, so I'm going to start by graphing -7. I would draw my number line if I didn't have any number line paper, and start with 0 and mark 1, 2, 3, 4, 5, 6, whatever. I'm going to mark at least as far as the numbers I have. And since I don't have anything past +5, but I do have a -7. So it looks like I ran out of room here, but I went ahead and put the -7. Okay, so to graph -7, even though it's still got the arrow there, we would probably want to pull that out just a little bit. I'm going to draw a circle, a closed circle on -7. Okay, to graph 0, I'm going to find 0 on the number line, and I'm going to graph a closed circle, which means it's all the way filled in, on 0. All right. The next one, I'm going to graph 5. 5 is right here, a closed circle on 5. Okay, so that is graphing numbers on the number line, graphing integers. I know you guys know what whole numbers are. These are integers. Okay, we're going to do the same thing with -4, -1, and 1. Okay, so -4 will be, you find the -4 on the number line, and you put a closed dot at -4. You're going to find -1 on the number line. You put a closed dot at -1. And you find 1 on the number line, and you put a closed dot at 1. Okay, these are all three considered closed dots. It is important that you put the dot and that you close the dot in, because in math, that represents, that means that one. If it's an open circle, which we'll talk about in the future, it has a different meaning. So make sure when you put your dot that it is a closed circle, a closed dot. Okay. All right, so now we're going to just talk very quickly about ordering these, okay? So if we're going to order integers from least to greatest, then we need to know what the least is and what the greatest is. So the best way to do that is to draw your number line, okay? And if you draw a number line, I'm going to search up here. I say -4, 0, +5, -2, +3, -3. So it looks like my smallest number is probably -4 and my largest number is 5. So I need to make sure that I have room on my number line when I draw it. I put a 0, that I've got a -4 and I have a +5, and I do. Okay. So now all I have to do is I label, well, I find -4 and I put it on the line. I take 0 and I'm going to put a closed circle on the line for 0. I take 5 and I put a closed circle on the line for 5. I'm going to find -2 and I put a closed circle on the line for -2. I find +3 and I draw a closed circle on the line for +3. And my last one is -3. And so I draw a closed circle on the line for -3. So now when I order my numbers from least to greatest, I can start at the very first of the number line and go to the very end, because as you go back from 0, the numbers get smaller. And as you go forward from 0, the numbers get bigger. So if you have, say, from 0 to 1, that's one more. And 1 to 2 is one more than 2 is one more than 1. And 2 to 3, 3 is one more than 2, and so on and so forth. Well, it's the same way. It doesn't switch. So from -1 to 0 is one more than -1. 0 is one more than -1. And from -2 to 1, -1 is one more than -2. So they're larger. They're actually larger. So as you go down the number line, the numbers get smaller. Just like if you are going up the number line, the numbers get larger, okay? So in ordering them from least to greatest, we're going to start with the first number we see on our left, and that's -4. Then we have -3. Then we have -2. Then we have 0. Then becomes +3. And the greatest of these order is +5. So this would be your answer if you were ordering from least to greatest. So you always start, the number to the left is always one smaller than its right-hand partner. That is the rule for ordering from least to greatest. Okay, so let's try some of these. It says order the integers negative or +4, -2, -5, 0, 2, and -1 from least to greatest. Okay, so what I'm going to do first is I'm going to go ahead and make my number line. I'm going to make sure that I have a -5, and so it's pretty small, and I got a +4, so it looks like it's my largest. So I need to make sure that I have those numbers on my number line when I draw it. Okay, and then I start to label. I'm going to start with +4. Just go in order that they are, because once you do that, then it will be easy to pick them out from least to greatest. So 4 is our first number. I draw a closed circle on the line. Then I go to -2, and I'm going to draw a closed circle at -2. Then my next number, and I can go ahead and mark these out just so I don't mix them up. My next number is -5, so I draw a closed circle at -5. Okay. Then my next number is 0, so I'm going to draw a closed circle at 0. My next number is 2. Draw a closed circle at 2. And my last number is going to be -1, so I will draw a closed circle at -1. Now, all I have to do is look at my number line, and I can list them from left to right, just like we read, to get from least to greatest. So I'm going to start with -5, then -2, then -1, then 0, then +2, then +4. And I have successfully labeled my integers from least to greatest using my number line. We're going to do one more. It says order the integers 3, 4, -2, -5, 1, -7 from least to greatest. Okay, so I'm going to start with my 3. Then label my 4. Then label my -2. Then I will go and label my -5. Okay. Then +1. And then last number is -7. It's all the way back here. Okay. Now I want to order these numbers from least to greatest. Now, I will say if we were going from greatest to least, obviously we would start at the 4 and go backwards, because 4 is greater than 3, which is greater than 1, which is greater than -2, which is greater than -5, which is greater than -7. But we want from least to greatest. So always make sure you read this part, because sometimes the question will ask you greatest to least, but this says least to greatest. So we're going to start at -7. Then -5, then -2, then +1, +3, and +4. So I have successfully ordered these from least to greatest. This is ordering integers from least to greatest on a number line, or using a number line. If you ever have to order numbers and you don't have a number line, all you have to do is draw a number line. It's very easy. Just draw it on your paper. Put an arrow to represent it continuously goes. If 0 is where you need to be, if you have numbers that are positive and negative, put the 0 in the center. If you have numbers that are all positive, you can just start in that section, or all negative, you can start in the, just make sure you have the list of numbers to be able to put on your number line. And then all you have to do is say 1, 2, 3, 4, 5. I mislabeled the 5, 6, 7, 8. I don't even label every number. I just go from 1, 2, 3, 4, 5, and I put a 5. And then I say 1, 2, 3, 4, -5, 6, 7, and that's -8. And that gives me reference points as to where my 5s are. And I can do that for the 10s and however else. But that's a very quick way that you can draw your number line. And then you can put your numbers on that line and order them. Okay? All right. Next slide. All right, so we've talked about integers, but now we're going to talk about all rational numbers. Okay? Rational numbers are all positive and negative integers. Okay, so we just talked about integers. All positive and negative integers, but they're also fractions and most decimals. Okay, so let's start with what integers. The integers are numbers like 1 and -1, 2 and -2. Okay, those are integers. Fractions are numbers that are like 1/4 and 2 and 1/6. Okay, and most decimals. Well, that's an interesting term. So that means that it's not all decimals, most decimals. So it says here, terminating and repeating decimals are considered rational numbers, okay? So what is a terminating decimal? Okay, a terminating decimal is actually a decimal that ends. So in other words, if you have the fraction 1/5, and you've turned that fraction into a decimal, if you say 1 divided by 5, you actually, and I can show you on the calculator here, if you say 1 divided by 5, you're going to get 2/10. So 1 divided by 5 is 2/10, okay? So that is 0.2 tenths. Now the reason it's called terminating is because it stops at 2. There are no bunch of other numbers behind it. It's just 2/10. And you could put a 0 behind it if you wanted it to be 20 hundredths or 200 thousandths or whatever, but it ends, it terminates. It doesn't have a whole bunch of string of numbers behind it to continue going. That is called a terminating decimal. Okay, it is a decimal that stops at some point. 1/2 is a terminating decimal because it is 0.5 or 5/10. 1/4 is a terminating decimal because you get 25 hundredths. Okay. 1/8 is a terminating decimal because you get 125 thousandths when you divide. 1 divided by 8. So those are all considered terminating decimals. Terminating decimals. Okay. Now, so if that's the case, then let's start looking at our Venn diagram here. Okay. So we've got this circle here that says integer. So inside this integer circle, I can put 1 and my -1 and my 2 and my -2. What other numbers could go into this integer circle? I could put 0. 0 is an integer. It's the integer between the positive numbers and the negative numbers. Okay. I could put 10. I could put 8. I could put -5. I could put -15. I could put an infinite number of positive and negative whole numbers, okay, inside this integers. All right. But outside of the integer circle, there's rational numbers, okay? So if I put my terminating or my fractions, who are also rational numbers, it says rational numbers are fractions. So I can add 1/4, okay? And 2 and 1/6, those are both fractions and they're considered rational numbers, okay? And I could add 1/3, okay? How about -1/5? That's a negative fraction, but it's also a rational number, okay? So all positive and negative rational fractions are considered rational numbers, okay? Now, let's talk about, we've got these terminating decimals here, and they're considered rational numbers, so I can put 0.25 down. That's considered a rational number. 0.5. How about -0.5? We'll make that a negative because that is also a rational number. We have 2/10, which is also a terminating decimal, so it's rational. We have 125 thousandths, so I'm going to make that negative because it doesn't matter, the positive or the negative, 125 thousandths. Okay, that's rational. All right, so we have covered that fractions and decimals, positive and negative fractions and decimals are considered rational numbers. And we've got this right here, it's called repeating decimals. So a repeating decimal is something that if you put it into the calculator, let's say I put the fraction 1/3 into the calculator. 1/3 in the calculator, 1 divided by 3, gives me 0.3333333 repeating, which that doesn't terminate. It doesn't end as a nice and neat like 2/10 or 5/10 or 25 hundredths or 125 thousandths. But it has a pattern. Okay. It has a pattern of 3. And if I was to ask you after all of these 3s, what is the next number in the sequence? You're going to tell me 3, okay? So this is called what a repeating decimal because it has a pattern that repeats. So that also, these are considered rational numbers. So we can put 0.3 repeating, and that's the repeating bar, okay? 0.3 repeating is a rational number. Let's see, what's another rational number? Let's pick one. Let's do 2 over 11. There's a pattern there. Now ignore the 2 because that just, the calculator rounds. So the pattern is 0.18, 18, 18, 18. And the reason that 2 that rounds because that one that would be there would have 8 behind it, and that rounds that up to 2. The calculator doesn't realize that. So it just is a pattern of 18. So 2/11 is also a repeating decimal, and the pattern is 1 over 8, and it repeats. So you put the repeating sign over the 1 and the 8, not just the last number, because that would mean just the last number repeated. Okay, let's look at the fraction 5 over 12. Okay, if you put 5 over 12 into the calculator, 5 divided by 12, okay, it also is 0.41666666, and that 7 just rounds up, so let's just look at it this way. Does this have a pattern? Is it repeating? What repeats? Okay, so I hope you said that the 6 is what's repeating. So this technically is considered a rational number too, because it is a decimal that has a repeating pattern. So here we would put into 5 over 12 would be 0.416. Now this one, you only put the repeating sign over the 6 because the 6 is the only thing that repeats. If you look at the calculator, the 4 and the 1 does not repeat, just the 6. So you make sure that you just put the repeating bar over the 6. Now all of these, I can make this one negative, I'll make that negative. All of these go into our rational number section because remember, terminating and repeating decimals are considered rational numbers. So I can put in 0.33 repeating. I can put in negative 0.18 with the 18 repeating. I can put in the 0.416 with the 6 repeating. That's 416 thousandths, which the thousandths is repeating. Okay, now, because I know that these are all fractions, and fractions are also, all positive and negative fractions are also considered rational numbers. So any fraction that you can turn into a decimal that has a pattern is going to be a rational number, okay? Now let's look at this diagram. We've got this diagram here, and it shows that we have integers on the inside, and then we have the rational numbers on the outside. So what this means is that even though fractions and decimals are not considered integers because we just have the whole numbers inside, all of these integers are considered rational numbers. So all integers, fractions, and most of our decimals, all terminating or repeating decimals, are considered rational numbers. So when we talk about adding, subtracting, multiplying, and dividing rational numbers, we're talking about the majority of numbers that you're used to dealing with on a daily basis. You may not have known that's what they were called, but that's what they are. So we are talking about this whole unit is over adding, subtracting, multiplying, and dividing rational numbers. So we're going to be using positive and negative integers, positive and negative fractions, and positive and negative terminating and repeating decimals. All right, let's go to the next slide. This one says graphing rational numbers on a number line. Let's move this up just a little bit. Sorry, I know it kind of freezes there. All right. All right, so it says draw a number line. So if we draw our number line, we just want to make sure that we have all the numbers that we're going to need. And I have this number line drawn from -6 to +6, okay? So to graph a rational number, you draw a dot in between the two integers that the rational number falls between, okay? So in other words, -5 1/2. If I go over here and I find 5 1/2, +5 1/2 goes between +5 and +6. So it makes sense that -5 1/2 would go between -5 and -6. It's mirrored the opposite way, but it still falls in those two numbers. So in between there, and since it's 1/2, we just go halfway between 5 and 6, and we place a dot right there. So this is -5 1/2. Now there again, I don't want you hovering that dot above the number line. We want you to place it on the number line as close to the spot that you can as possible. Okay. The next one is -2/3. Well, +2/3 is between the numbers 0 and 1. So -2/3 would be between the numbers 0 and -1. Okay. 0 and -1. Well, if we were to break this into little sections, we would have 1/3 and 2/3, right? So 1/3, 2/3, 3/3. That would be our little section. So 2/3 falls almost to -1, but not quite. It's 2/3 of the way. So we would put a dot right there. And this represents -2/3. And the last one we have for an example is +3 and 75/100. Okay, well, we know that 3 and 75/100 falls between +3 and +4. So we don't even have to reflect it across the number line there. +3 and +4. And I know that 1/2 is here and 75/100 is closer to 4 than it is 3. If I was to break this into 4 sections, that would be 25/100, 50/100, 75/100. So my 3 and 75/100 is right there. It's also the same as 3 and 3/4 if you wanted to make it a fraction. So 3 and 75/100 would be 1/4, 2/4, 3/4, 4/4 as a whole. Okay. That is how you are going to use your number line to locate rational numbers. Okay, next slide. We are going to talk about graphing rational numbers on a number line still. Okay, so if we are, this is our examples. So we're going to actually practice this. This is graph -2 and 5/10, +3/4, and +5 and 1 and 15/100. Okay, so we have enough numbers on our number line, and we're just going to do a general graphing on this. Okay, so if it's -2 and 5/10, I know that 2 1/2 or 2 and 5/10 falls between 2 and 3 on the positive number line. It's 2 1/2 is more than 2, it's less than 3, so 2 1/2 falls between 2 and 3. So it makes sense that if it's negative, it's going to fall between -2 and -3. So this is my spot that I'm going to be graphing, okay, between these two numbers. Well, since 0.5 is halfway, and I know that 0.5 or 5/10 or 50/100 is the same thing as 2 1/2 or 1/2, I'm going to go halfway and I'm going to draw a closed circle halfway between 2 and 3. And this represents -2 1/2. Okay, I'm going to go to my next number, which is 3/4. 3/4 is less than 1, but it's more than 0. So I'm going to be graphing between 0 and 1. I know this because 4/4 is actually 1, correct? 4/4 is actually 1. And 0/4 would be considered 0 if you were using the denominator 4. So I know that 3/4 falls between 0/4 and 4/4. All right, so if I was to break this out into little pieces, I could say 1/4, 2/4, 3/4, 4/4. So 0/4, 1/4, 2/4, 3/4, 4/4. All right, 3/4 is right here. It falls close to the 1 or to the 4/4, but not quite. And so this is 3/4. 5 and 1500ths. Okay. Well, I know between my 5 is greater than 5, less than 6. So I'm going to come up here and I know that my 5 goes between 5 and 6. Now 1500ths. It's like, how am I supposed to graph 1500ths? Well, I know that the 1 is in the tens place. And I know that's pretty close to just 5. That 15, if it's in the 100 spot, that's like 15 over 100, right? That would mean that I would have 100 tiny little marks between the 5 and the 6, right? Well, if I was counting 100 tiny little marks, and I don't really want to count 100 marks between this 5 and this 6, but I know that 15 is a whole lot closer to 0 than it is closer to 100. So I can just estimate my point being right about here, really close to the 5. And that is good enough if you were locating the dots on the number line and for a general number line graph. Okay, so this would be my estimate of 5 and 1500ths right there. Okay, all right. What two numbers does -4 and 5/10 fall between? I hope you said between -4 and -5, because 4.5 goes between 4 and 5. So -4.5 is going to, or 4 and 5/10 goes between -4 and -5/10. And since 5/10 is the same thing as half, I'm going to graph my number line, my dot, my closed circle between -4 and -5. One-fifth. Between what two numbers does 1/5 fall between? I hope you said between 0 and 1. So there are between 0 and 1, if you break it up into fifths, if your denominator is fifths, this would be 0/5, this would be 5/5, because anything over itself is 1. So if I was doing this for tenths, I would say 10/10. If it was for 6, it'd be 6/6. But this is for all intents and purposes, since 5 is our denominator, we say 0/5 to 5/5, which means I can break this number line into 5 sections. So I'm going to say 1/5, 2/5, 3/5, 4/5, 5/5. 5/5 is right there. So if I'm graphing 1/5, I'm going to put it right here on top of the very first hash mark, and that is my 1/5. Okay, my next number is -1 and 5/100ths. What two numbers does -1 and 5/100ths fall between? I hope you said between -1 and -2, because it's a little bit more than 1, but not quite 2. And like I said before with the 1500ths, I don't want to count 100 little dots here, because that 5/100ths means that you would break this number into 5/100ths. Well, I just know that 5 is a whole lot closer to 0 than it is closer to 1. So since I'm reflecting backwards, when you are using your number line, remember, you're closer to the 1. I'm going to put my dot right here, close circle, and put -1 and 5/100ths, and that is close enough. Okay, our last one is 2 and 6/10. 2 and 6/10 falls between 2 and 3. And if I was to break this up, since this is 6/10, this would be 6 out of 10. So I could literally say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's not even, but it's close enough. And I know that if I counted 1, 2, 3, 4, 5, 6, 6 is right about there. And 6 is a little bit past 1/2, which I know that. 5 if 5/10 is the same thing as 1/2, then 6/10 is just going to be one tick past it. So this is close enough. So this can represent 2 6/10. And that is how you locate and graph numbers on rational numbers on a number line. Alrighty. So what if you have numbers that are close together on a number line? So I'm looking at this. Sometimes you have to order numbers that are very close on the number line. And what does that mean? Okay, well, this has got a whole number of 4. This has a whole number of 4. This is a whole number of 4. Okay, 16/4 probably has a whole number of 4. 16 divided by 4. If you put that in the calculator, 16 divided by 4 is 4. So that is just the whole number 4. Okay, that's what that is. And then 4 and 624 thousandths. So all of these have 4 as their ones place. Okay, that means that if we were to do a regular number line and have 0 here, and we were to go 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5 on the negative way, then all of our numbers, all of our dots are going to be bunched up between the 4 and the 5. And that's going to be really hard to read. So we have a way that we can solve that, okay? What we're going to do is I'm going to just blow my number line up. Instead of having a number line that looks like this, where we have 0, 1, 2, 3, 4, 5, like this, I'm going to just zoom in on the 4 and the 5. And the way I'm going to do that is I'm going to say this is going to be the number 4. I'm going to start with this being 4. And since everything's positive, I'm going to say, and it's 4 and 75 hundredths, 4 and 1/4, 4 and 8/10, 4 and 4 and 624 thousandths. I'm going to use every one of these hash marks as like a tenth. Okay, when you have decimals and fractions, it's best to go ahead and convert everything into decimals and use a 10 base system. So that means this would be 4.1. This would be 4.2, 4.3, 4.4, 4.5, 4.6, 4.7, 4.8, 4.9, and 5, or 5.0, because we don't have a 4.10. Okay, this would be considered 10 base because it's each one of the decimal numbers is in the tens place. Okay, it would be like saying $4, $4.10, $4.20, $4.30, $4.40, $4.50, all the way to $5. Okay, that's what this represents. And I didn't have to use the other lines, and that's fine. So now let's go ahead and we can order our numbers on the number line. So I'm going to start with 4 and 75 hundredths. Okay, well, 4 and 75 hundredths, the 4 and 75, 4.7 is here, and 4.8 is here. And if this was 4.7, like I said, if it was 70 cents, and $4.80, $4.75 would land right about here, right in the center. And so this is going to be 4.75. All right, let's do the next one. 4 and 1/4. Well, if you take your calculator and you take 1/4, and some of you guys already know this, but 1 divided by 4 is 25 hundredths. It's like 1 out of 4 quarters. We talked about that in class.
Hey, do you have Natalie?
Okay, so 4, and if we have 25 hundredths, so that 4 and 1/4 is actually 4 and 25 hundredths. Okay, so 25, like I said, if this was 4 and 20 cents and this is 4 and 30 cents, 4 and 25 hundredths would be right here. halfway. Okay, so this represents 4 2500ths, right? Now we have 4 8/10. Well, 4 8/10 is on here, so we can, I'll just mark these out. 4 8/10 goes right on that crosshairs, right on the line. We can mark that one out. Then we have 16/4, which is, we converted to 4 a while ago, and 4.0 is just the same thing as 4, would go right here on this line. And then we have 4 624,000ths. Well, we're going to mainly focus on that tens place, okay? 4, because that 4.6 means it's going to be between 4.6 and 4.7, because 4.60 would mean it was just 4.6. And it's not quite 4.7, so we go to 4.6. Now, if we had 100 little spots in here, or 1,000 little spots, where would 24 be? Between the 6 and the 0.6 and the 0.7, the 24 would be pretty close to right there. It would not be way down here by the 0.7. It's going to be a whole lot closer to the 0.6. So we're going to put a dot right here, and that's going to represent 4 624,000ths. Let me mark 4. And that is all. So now if I wanted to order these from least to greatest, I could go and say 4, and then I could write 0.25 or just go back up here and put 4 1/4, because that's what it came in, 4 1/4. Then 4 624,000ths. That would be next. I didn't label 4.8. 4 7500ths is next. And then 4 8/10 is the last one. So this is how you use a number line to order rational numbers that are very close together. Okay, you can do the exact same thing on if you have negative numbers, okay, as you do if you have positive. Now, what I did was I actually just did the negative version of the positive number line we just did. So before we had, when we looked at our number line, we had 4 here, and we had 5 here. So we had 4.0, 0.1, 0.2, 0.3, 0.4. Well, we know from looking at the bigger number line that if we are going to use on a negative number line, the numbers are reflected backwards. It says you can order negative rational numbers that are very close on a number line, the same as positive rational numbers, except it is reflected backward. Okay, so that means, and these, like I said, these are the same numbers, except for they're all negatives. So we're going to start, we know that negative 16/4 is just -4, right? We already figured that out. So I'm going to start here instead of over here, and I'm going to say -4.0. -4.1, -4.2, -4.3, -4.4, -4.5, -4.6, -4.7, -4.8, -4.9, and -5.0. And that's all I need, because all of my numbers are between -4 and -5. Okay, so the same rules apply, except, like I said, everything is backwards. So we're going to start with -4 7500ths. And so if this was, I'm going to look for between the 70 and the 80. Okay, I'm going to look between -4 and 7000ths and -4 and 8000ths. So right here, I see the -7. Now, lots of students want to go this way because they're so used to it being positive and they're putting it here. But that's actually between the -6, 4.6, and the -4.7. So don't make that mistake. Remember, it's backwards. So you're actually looking in between this spot right here, -4.7 and -4.8. So I'm going to say that 75 hundredths is going to be halfway between, because it's negative 4.7 and negative 4.8, 70 and 80. That would be 75 would be halfway. And so this represents negative 4.75. Okay. Now negative 4 1/4, and we figured out earlier that that is negative 4 25 hundredths. So we're going to look between the negative 4.2 and the negative 4.3. So negative 4.2 and negative 4.3 are right here. Okay. So remember, you're going backwards. So if this was negative 4.20 and this is negative 4.30, or $4.20, $4.30, then negative $4.25 is going to be halfway. So this represents negative 4.25. Negative 4.8, just go down here, and you're going to label negative 4.8. Negative 4, you're going to mark negative 4 right here, which is 16/4, correct? And negative 4 and 624 thousandths, remember it's going to be between the negative 4.6 and the negative 4.7. So that is right here, negative 4.6 and 4.7. And the 24 thousandths is going to be closer. If that was 1,000 little marks between the 6 and the 7 here, you're going to be closer to the negative 4.6 than you are the negative 4.7. 624 is closer to there than it is to the 0.700. So we are going to label that negative 4 and 624 thousandths. All right. So now when it says order these from least to greatest, our least number is actually the negative 4 8/10, because it is further down the number line than our 4. Okay. So we're going to say negative 4 8/10 is least. Then negative 4 75 hundredths. Then we have negative 4 624 thousandths. Then we have, and that's 4 25 hundredths is actually negative 4 1/4. And then the last one, I think I wrote 4 on the other page, but it's actually negative 16/4, right? Because that's negative 4. So this is writing them from least to greatest on the negative side. Now, if you look, they are the opposite way from the positive and negative. On the positive side, that was actually 16/4. 16/4 was first because it was the smallest. 4 is smaller than 5. But on the negative way, the negative 4/8 is the smallest because it's further away. It's further to the left on the number line. So everything is the opposite, is reflected opposite. Which brings me to the next thing we're going to talk about, which is the distance from 0. Okay? We're going to talk about absolute value. And we're going to talk about opposites in just a minute, but let's start with absolute value. Okay, so we have the absolute value of a number is just its distance from 0, guys. It's distance from 0. So in other words, on a number line, if you have the number 5, the absolute value, which that's what these little marks are, these little marks right here are called absolute value marks. I like to call them field goal marks because it looks like it reminds me of when you watch football. When you make a field goal, the ref will throw his arms up in the air and it makes the field goal lines. Well, these are like my little field goal symbols, what it looks like to me. So this is my field goal, okay? Absolute value means that the absolute value of 5, its distance from 0 is 5. Well, the absolute value of a negative 5 is also a distance from 0 is 5. And distance cannot be negative okay? It cannot be negative because you don't walk negative steps. You don't drive negative miles. You may drive to a place and drive home from a place, but you don't go, it's never negative miles. Distance is never negative. So 5, the absolute value of 5 is 5. The absolute value of negative 5 is also 5. The absolute value of 0 is just 0 because you can't, it's already on 0. Okay? Remember, distance cannot be negative. Okay, with that said, we are going to evaluate the absolute value. It says, ask yourself, how far is the number from 0? So if you look on the number line, and we have this number line for you, it says the absolute value of -4. Absolute value of -4, if you look at -4, you can say 1, 2, 3, 4. So it's 4 places. Okay. 3.6, what is the absolute value of 3 6/10? Well, if you go here, 6/10 is right about there. If you look from 0 to 3 6/10, you are 3 6/10 places away. So 3 6/10. Okay, the absolute value of 7 minus 3. Well, what is 7 minus 3? 7 minus 3, or 4, sorry, I'm saying the answer. 7 minus 4 equals 3. So the absolute value of 3 is 3 places away. So you're 1, 2, 3. So the absolute value of 3 is just 3. Okay, so even if you add or subtract or multiply and divide in here, you still, with those absolute value marks, it's still asking you, how far is the distance from 0 of your answer? Okay, 8 3/10 minus 3 1500. Let's see. We'll get the calculator for that one. 8 3/10 minus 3 1500, and that gives you 5 1500. So that would, we'd put the absolute value signs, 5 1500. So what is the absolute value of 5 1500? I hope you said 5 1500, because it is just 5 1500 places from 0. Okay. All right, so we're going to do some more. It says, ask yourself how far the number is from 0, and these are all different types of absolute values, okay? So we have the number line here for reference. We're going to first start with solving the problem inside the absolute value marks, and then we will put it in absolute value marks and then decide how far it is away from 0. So the first thing we do is we say that 12 divided by 4, 12 divided by 4 is 3. So what is the absolute value of 3? It's just 3, because 3 is just 3 spots away from 0. Okay. Well, this dot is actually a time sign. So 3 times 1/3, I don't know if you guys know this, but it's going to be 1. But I'll show you on the calculator. Anytime you multiply a whole number times it's what we call the fraction, the number on the bottom of it with the 1 on top is actually called its reciprocal. So 1/3, multiply that by, it's going to give you 1. So the absolute value 1, how far is 1 away from 0? It's 1. Okay, let's look at number 3. Okay, so we have, now there's something new here, just keep that in mind, but it's outside the absolute value marks, so we're not going to worry about it right this second, okay? Let's solve what's inside these absolute value marks, because they're kind of like parentheses too. You solve what's inside them first. 9 minus 1, and we have not gotten to this point in our doing a positive negative number, so I'm just going to say, I want you guys to see right here, see that negative button? That's how you take negative. So you're going to say negative, see the negative on the calculator? -9 plus 1 is going to equal -8. So I'm going to put the negative sign here and put -8, because that goes inside those absolute value marks, -8, right? minus 1 plus 2 is just 3, okay? All right, so we have the absolute value of -8 minus the absolute value of, well, the absolute value of, I've got the negative, sorry. The absolute value of -8 minus the absolute value of 3, all right? Well, this is crazy, but the absolute value of -8 is just 8, right? And then we have minus the absolute value of 3, which is 3. But we still have this negative sign. So if you see a negative sign on the outside of your absolute value, you actually have to bring that down. So we're going to bring that down. So that makes it negative again. And that's tricky. And the reason I wanted to show you that is because the rules of math, which we talk about order of operations later, you work on the inside and then you go outside. And since that negative is still there, you still have to bring it down. So now we have -8 minus 3. Okay, so because the absolute value of positive 3 is just 3, but we have that minus sign there. Okay, so we're saying take away 8 or take away 3, or -8 minus 3. So -8 minus 3, if you guys want to put that on your calculator, -8 minus 3, I can use a negative sign to do the 8 minus 3, and that gives me -11. So this answer is actually a negative number, even though absolute value, we had the distance of -8 and minus the distance of 3. And that gives us -11. And that was a hard one. All right, last one. This one's a little easier, even though it looks harder. We're going to take the absolute value of 8 minus 3 and 42/100. Well, let's just subtract inside these. So we have 8 minus 3 and 42/100. And that gives us 4 and 58/100, okay? So this is 4 and 58/100 absolute value. Now there's no negative sign, so we don't have to worry about that. So we're saying the distance of these two numbers is 4 and 58/100 away from 0. Plus the distance of 20 minus 20. Well, anything minus itself is 0, right? So the absolute value of 0 is just 0. So we're basically saying the absolute value of 4 and 58/100 minus the absolute value of 0, or plus the absolute value of 0, is just 4 and 58/100. It's 4 and 58/100 away from the 0. Now these are some pretty complicated problems, but this is how the absolute value works. And you must remember to say, how far am I away from 0 when you see the absolute value marks. Always put your absolute value numbers that you want it to be away from the distance from 0 in our little, what I call field goal signs. Okay, one of the last things that we're going to discuss is going to be opposites, okay? And we've already kind of talked about this, but we're really going to talk about what that means. So you guys remember way back when we talked about positive and negative numbers? Okay, it says two numbers that have the same absolute value but different signs are called opposites. So if we talked about +2 and -2, or in our example here, +6 and -6, the absolute value of +6 is just 6 because it's 6 parts from 0. Well, the absolute value of -6 is also 6 because it's 6 places from 0. So opposites mean that they are the same distance from 0. So it's going to be the same number, but one's going to be the positive version and the other is the negative version. So these are actually called your whole numbers and their opposites, okay? The only number that doesn't have an opposite. What is the only number that doesn't have an opposite? If you said 0, you're correct. This is the only number because 0 basically is its own opposite. It doesn't have a pair. The others do. 0 is the very center of the number line. All right, so let's try this. What is the opposite of 5? I hope you said -5. Look at 0. if 0 is 5 places away from 5, then 0 is also 5 places away from -5. What is the opposite of -3 and 5/10? I hope you said +3 and 5/10. Look where 3 and 5/10 would be. It'd be halfway between the 3 and the 4. Halfway between the 3 and the 4 here, the -3 and the -4. They are on the opposite sides of the number line from the 0. Okay, what is the opposite of 1/2? I hope you said -1/2. If you locate 1/2, which is between 0 and 1, it's going to be about right where that circle stops, actually. And on the other side, look at there, -1/2. So they mirror image each other. And that's a pretty easy concept, but you always have to remember the difference between the opposite and the absolute value. The opposites are the positive and negatives of each other, and the absolute value is the distance from 0. Okay? So 6 and -6 are opposites, but they both have the same absolute value. The last thing we're going to talk about is absolute value in real life. Okay? These are called vertical number lines. A vertical number line is just a regular number line, but it's going up and down. It's going vertically. Makes sense, right? So the graph shows the position of a diver relative to sea level. Well, sea level, guys, in any time you're talking about anything, when you're talking about altitude on a map or anywhere else, sea level is always going to be at 0, okay? It's where the sea meets the sky. Use the absolute value to find the diver's distance from the surface. Well, the diver's way down here, right? I see the diver right down here. See? It's like, where's Waldo there? Okay. Now I see that the diver looks like he's got the on -18. Okay. So where would we say that he was in for absolute value? Okay, so I'm hoping that you are looking at this and you say, well, since it says -18 and we're talking about the absolute value, so I'm going to put -18. The absolute value of -18 is going to be 18. So if I was going to restate this, I would say, and it says in feet, so the diver is 18 feet below sea level. And that below represents the negative part because we know he's in the water. So we can say 18 feet. Okay, we don't have to put the negative there. Okay. The next one says the graph shows the depth of a well in feet. Use the absolute value to find the distance the well must travel to reach the surface. It looks like the well is right here. And I want you guys to tell me what is the absolute value of the well's depth below the surface. I hope you said the absolute value. We're halfway there, so it's 250. So it's between -200, -300. So the absolute value of -250 is going to be 250 feet. So the well is 250 feet below the surface. Okay, I know this has been a really long lesson, but we have just covered a lot of material. And you guys are going to start this week by doing all of the information on rational numbers, which is integers, fractions, and most decimals, and absolute value, and opposites.